Very good morning, children. Welcome back to part 2 video of class 10 science chapter 11. So in this video we're going to discuss on few phenomena and the daily life application. So the first thing in this we have to learn is dispersion of light. So in the last video we learned about human eye, and then we learned about power of accommodation, means how much we can see, how much near we can see, how far we can see, and then we learned about a refraction of light through a prism. So the next topic is dispersion of white light. Dispersion of white light through a prism. So when Newton experimented, the white light, when it enters through a glass prism, what happens is, earlier you have seen it bent, and why it bends? Because it is entering from a rarer medium to a denser medium. उसका actual जो ray of incident है या incident ray या incident path, उसमें से वो थोड़ा सा deviate होता है, bend towards the normal हो जाती है. But when it bends, it splits into 7 colors. Vibgyor: violet, indigo, blue, green, yellow, orange, red. So it splits into 7 colors. Violet, indigo, blue, green, yellow, orange, red. And the most deviated ray is violet, and the least deviated ray is red. And when I say in terms of wavelength that you have learned in class 9, lambda, it is a smaller wavelength, it has a greater wavelength. In terms of frequency, if I say, it has a greater frequency and it has a smaller frequency. So in terms of wavelength, let's say wavelength को हम lambda से denote करते हैं. So the greater the lambda is, least is the deviation. And then we can see these at this surface again deviates. So the 7 colors you get obtained, so they never cross each other here. Okay, so Vibgyor, because the second surface it deviates again. So in the first surface it deviates less and disperses less, but in the second surface it disperses much wider angle. So the dispersion or the deviation is inversely proportional to the lambda here. So wavelength जिसका कम है वो ज़्यादा deviate हो रहा है, और wavelength ज़्यादा है वो कम deviate हो रहा है. So Newton actually thought that maybe due to the color, due to the property of this glass slab, the glass prism, maybe these colors are coming up. Maybe the colors are already there in the glass slab. So he was like, first of all, thinking that it might be a property of glass slab. So then he experimented with the more glass prisms so that he was waiting, expecting to see more colors, not only the 7 or more colors, but he did not get it. He got the same 7 colors. But when he experimented with one more prism in a sense, one more prism which is just upside down like this, then what he observed was, this ray again refracted back to give a white light. So if I make it very short, it would be like this, very small, because it does not go for a big angle. So get a white light, parallel white light. So you get a white light again. So this experiment proved to him that this is not the property of the glass lamp. This is a property of the light actually. When it enters the glass lamp, it splits into several colors, and the several colors again join to form the same white light, because it is not a property of glass lamp, it is a property of the white light. The white light contained 7 colors. So earlier it was never thought that how come this white light has colors? White light is white. How can it, it consists of different frequencies, different wavelengths. So white light is not a single frequency. White light is not a single wavelength. It is a mixture of few wavelengths. So if I say the definition of dispersion of light is the splitting of light into its component colors. Splitting of light into its component colors is called dispersion of light. So let's see an example, a daily life application of dispersion of light, that is formation of rainbow. So why it disperses, that is a matter of higher classes, but I'd like to give you just a brief idea, in one word idea, why it disperses. The simple reason is a refractive index. So refractive index for different wavelength is slightly different. For example, the refractive index for red light is 1.5, 1. Then VGO, violet, indigo, green, orange, red, blue, green, orange, red. So for orange it may be 1.52, yellow it may be 1.53. A very small variation of refractive index is there. So refractive index not only depends on the medium, it also depends on the frequency of light. So for different frequency of light, the refractive index is slightly different, because of which because of which I can say that the light splits, because different deviation is there. So greater refractive index, greater deviation. Smaller refractive index, smaller deviation. So different colors has different deviation. So when it different deviate, then it gets into different paths. So when it gets into different path, then we can see as different colors. Okay, so even this is also called spectrum of light. So ये जो VGO हमने यहाँ पे बनाई, इसके one word में हम बोलते हैं spectrum of light. Spectrum means a collection of wavelengths, collection of frequencies, and a collection of the component colors in that particular light, whatever it is. सो ट्यूबलाइट में इतना 7 कलर नहीं होता, बट लेस कलर्स है ना. एडिसन बल्ब का जो लाइट होता है उसमें और लेस कलर होता है, मे बी 3 कलर, मे बी 4 कलर, बट द सनलाइट हैज 7 कलर्स. So we have one of the application of this dispersion of light. Even you can see, you can sense this dispersion of light through a scale, and if you look through a scale, then you can see different colors. Anyway, but a substantial phenomena that we can see is formation of rainbow. Formation of rainbow. So now the question is how a rainbow is formed. So we can just go for a proper diagram. So I will draw you both the diagrams, the actual diagram and the NCERT diagram. So actual diagram is just to understand that what reaches first and what reaches later. What color appears in the upper part of the sky and what color appears in the lower part of the sky. So when there is a rain shower, a lot of suspended water droplets are there in the atmosphere. So when the ray of light, after rain shower, when you can see the sun, the ray of light goes through these all suspended water droplets and they undergo dispersion. So I'm drawing a water droplet lights, and there is a dispersion of light. And how the dispersion of light? Why the dispersion of light? Because it enters from a rarer medium to a denser medium, just like we have learned in the prism, from a rarer medium to a denser medium. Then due to the different refractiveness for different colors, different wavelengths, then the red light, it deviates less, violet deviates more. So if I draw the normal for a circle, how will I draw the normal? So you see how to draw a normal for circle, because for a surface we can easily draw the normal. When a ray of light is incident, then the normal is perpendicular to the surface, and here the normal is perpendicular to the tangent, like this. So the normal which is perpendicular to the tangent is actually the radius itself. So radius is the normal here. So radius is a normal. So I am going to draw normal with dotted lines. Okay, in order to understand the path of the ray which get deviated. So it bent towards the normal because air to water. So rarer to denser medium. So it bent towards the normal. So it should go like this, but it bends towards the normal. And then at this particular point, again you can draw the normal, means radius is a normal. So it must go like this outwards, but we know that when a ray of light passes from a denser medium to a rarer medium, it bends away from the normal. So ऐसे जाने की बजाय it bends away means like this. So लेकिन एक पर्टिकुलर एंगल ऑफ इंसिडेंस के लिए कई बार ये जो एवे जो है इतना एवे हो जाता है कि इट गोज बैक इनटू द, इतना ज्यादा एवे हो जाता है, इट गोज बैक इनटू द वाटर ड्रॉप इटसेल्फ, व्हिच इज कॉल्ड टोटल इंटरनल रिफ्लेक्शन. टोटल इंटरनल रिफ्लेक्शन. And then again we can draw a normal, means radius is a normal, and then it must pass outside. Like again the same problem is there. What is the problem? The light moves from a denser medium to a rarer medium, so it bent away. So away means like this, so it bends away like this, away from the normal. So it ज़्यादा ही away हो गया, थोड़ा सा कम away कर लिया, ठीक है, it bends away from the normal. So this is a ray of light entering the man, which is over here, who is watching. Okay, so entering the person who is watching over here. So I can draw you simply an eye. So a person watching over here will see in this direction a rainbow. In this direction a rainbow. So here you will see a rainbow. So here is the sun. So opposite of the sun. Always rainbow is observed on the opposite side of the sun. क्योंकि हमें ऐसा लगता है कि जो रे ऑफ लाइट हमारी आंखों में एंटर होता है उसी डायरेक्शन में हमें वी सी थिंग्स, उसी डायरेक्शन में हमें चीजों को दिखता है. So here I am going to explain the dispersion. Here I have explained only the refraction now, how it refracts. लेकिन हम जानते हैं कि जब भी ऐसे डिविएट हो रहा है तो रेड लाइट कम डिविएट होता है और वायलेट लाइट ज्यादा डिविएट होता है. सो सपोज दिस इज अ वायलेट लाइट जो ज्यादा डिविएट हो रहा है. सो रेड लाइट की बात करते हैं तो रेड लाइट थोड़ा सा कम डिविएट हो रहा है. यहां पर भी रेड लाइट थोड़ा सा कम डिविएट हो रहा है. कम डिविएट हो रहा है तो मतलब ज्यादा डिविएट हो गया तो और इधर आएगा. कम डिविएट हो गया तो इसको क्रॉस करके जाएगा. और रेड लाइट और कम डिविएट हो रहा है. So this is a red light and this is a violet light. So the red light को अगर आप पीछे की तरफ करेंगे so this will become again here is red and here is violet. Okay. So मैंने एक और रे बनाया जो कम डिविएट वाला था, that was the red. क्योंकि less wavelength जो है greater wavelength जो है वो कम डिविएट होता है, inversely proportional. Deviation angle we can say that it is inversely proportional to lambda. So I'm very clear what appears in the upper part of the sky. The upper part of the rainbow is red color. The lower part is violet color. So that is a reason. This is a reason why. क्योंकि ये रेड और नीचे है तो ये ऊपर की तरफ होगी. सो क्योंकि आप जानते हैं कि ऐसा कोई रे है और ऐसे कोई रे है. सो ये वायलेट है तो वायलेट पहले ऊपर जो है वो नीचे आएगा और जो नीचे जो है वो ऊपर जाएगा. सो दिस इज अ एक्चुअल डायग्राम ऑफ formation of rainbow by refraction of light. But the thing you have to understand is NCERT has not given a detailed information like this. So NCERT का डायग्राम कैसे बनाएंगे? NCERT डायग्राम में यहाँ पर ये जो रे ऑफ लाइट है ये क्रॉस नहीं कर रहा है. ये दो पतला रे ऐसे आ रहा है, फिर दो पतला रे ऐसे आ रहा है, फिर दो पतला रे ऐसे आ रहा है, फिर वो दो पतला रे को पीछे की तरफ ले जा रहा है और रेनबो फॉर्म हो रहा है. और उसमें आपको बाहर करना पड़ेगा कि ऊपर रेड लाइट आ रहा है और नीचे वायलेट लाइट आ रहा है. बट दिस इज एक्चुअल और वेयर यू कैन यू नो टेक आउट दिस नॉर्मल्स. क्योंकि नॉर्मल जो है ये सिर्फ बेंड टूवर्ड्स नॉर्मल है या बेंड अवे फ्रॉम द नॉर्मल है, तो वो दिखाने के लिए मैंने ये सब बनाया. अदरवाइज ये नॉर्मल का जरूरत यहाँ पर बिल्कुल भी नहीं है. So I have deleted the normal here now. So when a person looks from here, he can see red light in the upper part and violet light in the lower part of the rainbow. So this is called primary rainbow. Even there is one more type of rainbow which is called secondary rainbow. In primary rainbow, the ray of light passes from the upper part of the water droplet. But in the secondary rainbow, if that is not given in your textbook, there is something called secondary rainbow also, because sometimes you can see two rainbows. One rainbow is very colorful and other is light in color. So secondary rainbow is hardly seen. And even primary rainbow bhi ek after rain, when the sun comes up in the sunshine, you can see opposite of the sun, you can see the rainbow. The reason is this phenomena, refraction and total internal reflection. So यहाँ पर refraction हो रहा है और dispersion of light भी हो रहा है. और यहाँ पर रिफ्रैक्शन की वजह से डिस्पर्शन ऑफ लाइट तो हो रहा है, बट टोटल इंटरनल रिफ्लेक्शन भी हो रहा है, एंड हियर अगेन डिस्पर्शन. सो डिस्पर्शन, टोटल रिफ्लेक्शन and dispersion. So these are the three steps. Dispersion of light, when it refracts it disperses, क्योंकि रिफ्रैक्शन की वजह से डिस्पर्शन हो रहा है, और when it refracts actually total internal reflection takes place, and here when it refracts again more dispersion takes place. So this is how the dispersion of light occurs in a water droplets. So there are thousands of droplets, the same thing happens, and all those things produce a visible, a bright rainbow. एक दो वाटर ड्रॉपलेट से जो बनेगा वो तो रेनबो दिखेगा भी नहीं, because you need more brightness, means more number of rays, more such water droplets to make this phenomena visible. So you can learn the diagram of NCERT for example, but this one I have made for your clear understanding कि कौन सा कलर ऊपर दिखेगा, कौन सा कलर नीचे दिखेगा, उसके लिए मैंने ये बनाया है. लेकिन ज़रूरी नहीं है कि आप इस डायग्राम को लर्न करें. द डायग्राम दैट NCERT gives is a little bit simple. So NCERT के डायग्राम अगर मैं बनाऊं तो you can make it like this. So the diagram of NCERT is so this is the diagram of NCERT, where Vujor is found. So NCERT does not use the actual information there. और ऐसे डायग्राम, तो ऐसे डायग्राम आप लर्न कर सकते हो, कोई दिक्कत नहीं है, क्योंकि देयर इज मच मोर knowledge in physics is required to draw properly. So what about secondary rainbow? What about secondary rainbow? So when I say about secondary rainbow, there is, so here is one total interreflection is there, and two refractions along with dispersion is there. So dispersion means splitting of white light into its 7 component colors. So when a ray of light is passes from air to water drop, then it refracts and disperses, and then when it try to comes out of the water drop, it totally reflect. Total internal reflection takes place. So 3 processes you have to explain properly, and after total reflection, then it again disperses as it comes out of the rainbow, or comes out of the water drop. Okay, so let's go for the secondary rainbow, but it is not for the examination point of view, only for your knowledge. Secondary rainbow is when a ray of light is incident at the lower part of the water drop. Then there is a refraction, because we already know it should not go like this, it will bend towards the normal. So it bends towards the normal like this, and again it must go outside, so it must bend away from the normal. So this is a normal, so bend away from the normal means like this. So sometimes it bends at particular angles, bends like this, and then again it must to bend away from the normal. So away from the normal, again it bends like this. So you see, there is a first total internal reflection TIR takes place here, and the second TIR takes place here, total internal reflection, and then here also you can draw a normal which is radius itself is a normal, और ये सीधा जाना चाहिए लेकिन it will bend away from the normal. So this is a normal, तो normal से away मतलब larger angle बनाएगा, so it will go like this. So for a person standing here can see a rainbow in this direction, and the sun must be here because the sunlight is coming from here. The sun must be somewhere here. So the person must face in the opposite side of the sun. Then only he can see the ray of light. So where this ray of light you can see at a higher place. So even if we go for this as a red one, suppose. Yeah, you can go for this as a violet one, the red will deviate less. And the red deviate again less. The red deviate again less. And the red deviate again less. So this is red and this is white. So violet will automatically go up. And the red will automatically go down. So this rainbow is just opposite, violet in the upper portion and red in the lower portion. But this such rays which is entering through the lower side of the water drop are very less. So the intensity, the brightness of the rainbow is very less. So it's a very feeble, and sometimes you cannot see at all the secondary rainbow. So very feeble rainbow is formed, with the violet on the upper part and the red on the lower part of the rainbow. So this is not anyway in your syllabus, so I have just said for your information only. You don't need to learn and you don't need to write all these things in your copy. You have to write the primary rainbow in your intro. So the next topic that we are going to learn is here atmospheric refraction. So atmospheric refraction का example मैं बताऊं, if the sun is very hot and you can see the air near the road or air near the land, sand is very hot, and when you look through a hot air you can see the image over there. When you look through a hot air, तो hot air के अंदर से अगर आप कोई आगे जो पौधा है, आगे कोई बोर्ड है, कुछ भी है, उसको देखते हैं तो you can see that board is shivering due to the atmospheric refraction of light, क्योंकि hot air का refractive index कम है. So hot air rises. So as a hot air raises, the variation of refractive index is there. So as the refractive index varies, then what happens is, and sometimes you can see the apparent position of the object there, it also varies. So when the apparent position of the object varies, you will feel like the object is shivering. So ये smaller scale में होता है जब अपन एक hot air के through somebody is making tea, suppose, in the shop, and you can see that in the whereabouts of where it is made, you can see when you look through that the images behind those air will shiver, because a hot air is going up and the refractive index of the air over there varies, and then the position of the image that you can see, it also varies. So it look like that something is shivering there. और इसका better explanation अगर मैं बताऊँ आपको, the twinkling of stars. Twinkling of stars. Atmospheric refraction का एक better example है twinkling of stars. So we feel like the stars are sometimes appearing bright and sometimes dims and bright and dims. These are called actually twinkling of stars. तारे टिमटिमाते हैं, मतलब वो थोड़ा bright हो जाती है, फिर थोड़ा dull हो जाता है, bright हो जाता है, dull हो जाता है. So this twinkling of stars is due to Actually, the stars do not twinkle. One of the star is the sun itself. क्या सन ट्विंकल करता है? सन का लाइट कभी ज़्यादा कभी कम, कभी ज़्यादा कभी कम, है ना? हमारे लिए ज़्यादा कम इसलिए होता है बिकॉज इन द मॉर्निंग द लाइट हैज़ टू ट्रैवल ए लॉन्ग डिस्टेंस, बट इन द आफ्टरनून लाइट हैज़ टू ट्रैवल ए less distance. But in the afternoon, if you look to the sun, in the morning if you look to the sun has the same brightness, but in the afternoon the brightness increases, but increases gradually. But it's not that the same time you are looking and it dims and it goes bright and it goes dim, it goes bright, it goes dim. It does not happen. And the reason is the sun is very, very near to us. So let's see about stars actually. So we are on the surface of the earth, and earth has an atmosphere over almost 500 kilometer, but the thick atmosphere is very few kilometers only, and then the atmosphere is very, very thin. Very, very thin means the refractive index is very, very less. So here, as a person look from the earth's surface, the different layers has different refractive index. At the lower part near the surface of the earth, the refractive index is greater, and the upper part refractive index is very, very less. So there is a gradual decrease of refractive index is there. But we know that due to atmospheric condition, and there is wind, there is sunlight, there is a hot air going up and a cold air coming in. So a lot of atmospheric climatic conditions are not stable. There is cloud and the clouds are moving. So due to the variation of refractive index, and the variation of refractive index is not stable, and sometimes somewhere it is greater, sometimes it is less. So due to the condition of atmosphere, the way varies, fluctuates. So the density of the atmosphere is not exactly the same always. It fluctuates. So then, suppose star is here, and the ray of light comes to the atmosphere. So atmosphere का अलग-अलग layer है, अलग-अलग layer में अलग-अलग. So it bends towards the normal. So अगर आप इसमें radius बनाएंगे तो it will bend towards the normal. So almost like this. So it bends. Straight line में नहीं जाता. So somewhere star you can see somewhere here. The apparent position of the star is this. But this apparent position of the star fluctuates because the atmospheric conditions fluctuates, varies. So as the atmospheric conditions varies, then the apparent position of the star also varies. Somewhere it is here, somewhere here, somewhere there. So when the apparent position of this star varies, the person looking from here, sometime he will get more light into his eyes, and sometime he will get less light. And one of the important reason behind is the star is a very distant object. So very distant object है, तो जैसे मैंने अभी आपको एग्जाम्पल में लास्ट वीडियो में बताया कि सारे रे ऑफ लाइट आपके आईज में नहीं आएगी. जितना आप दूर जाएंगे very less number of rays enter your eyes. So that is why we are not able to see. और हमने बहुत दूर जो चीज है वो इसीलिए नहीं दिखता, ऐसा करके मैंने आपको लास्ट वीडियो में एक्सप्लेन किया था. So here the star is a very distant object and very less number of rays. For a distant object, when we talk about the number of rays, so object is somewhere here, and if you are very near, then a lot of rays are going through this. But the same object, if you keep it here, very less number of rays are passing through it. So that is the reason behind very less number. The same object, if you keep it here, very less number of rays the same size, the same size, but very less number of rays penetrating. But here a lot of rays. So that is the reason when a star is very distant, when an object, light emitting object is very far away from you, then very less number of rays, and our eyes are very small, and the distant starlight, very less starlight enter our eye, and sometimes we feel more light enters our eye, so the star appears brighter, and very less number of rays enters our eye, then star appears dimmer. So that is why there is a dim or bright twinkling of stars, of course. And what about moon? Is it moon also does the same? Moon does not twinkle. The simple reason is moon is very near to us. It is not a distant object. So अगर आप moon को देखेंगे instead of this sun, instead of this star, if we take moon, stars are millions of light years even away. We are very, हमारे जो यूनिवर्स के बारे में स्टडी करने का हमारा जो प्रोग्रेशन है वो अभी कहाँ तक पहुँचा है. इवन वी आर नॉट एबल टू फिजिकली गो फिजिकली सेंड ए पर्सन इनटू मार्स राइट नाउ. इस हालत में हम तो मार्स तो हमारी सोलर सिस्टम में हमारा नेक्स्ट प्लैनेट है. देयर आर 9 प्लैनेट्स और उसमें से एक को अभी प्लैनेट बोलते हैं नहीं बोलते हैं. एनीवे दैट्स नॉट आवर इश्यू. और ये प्लैनेट सिर्फ सोलर सिस्टम की बात हो रहा है. इस तरह पता नहीं कितनी सोलर सिस्टम्स है और ये सारे सोलर सिस्टम्स जिन सोलर सिस्टम्स में बहुत सारा ग्रुप ऑफ सोलर सिस्टम्स है उसमें एक सोलर सिस्टम हमारी अर्थ के है ना. सन के चारों तरफ घूमने वाले कुछ प्लैनेट्स हैं और इस सोलर सिस्टम एक बहुत बड़ा group of stars में है which is called, which I can call Milky Way, and then इस तरह और भी groups of stars हैं, different groups of stars हैं which makes the universe. So हम stars में दूसरी स्टार में जाने का या दूसरी स्टार तक पहुंचने का वो एक सपना ही है अभी. Even for us we are not able, till today we are not able to reach Mars even. हमने प्रॉप्स को भेजा है, रोबोट्स को भेजा है, लेकिन अभी तक ह्यूमन बीइंग को नहीं भेजा है. ह्यूमन बीइंग तो सिर्फ मून में गया बिकॉज मून इज वेरी नियर. मून इज अ सैटेलाइट ऑफ अर्थ. So when we compare about other planets and when we talk about other stars, they are much far away. So मून की बात करें तो बहुत पास में है और मून में भी अगर आप मान लो मून को बहुत छोटे पॉइंट ऑब्जेक्ट्स में बांटेंगे तो स्टार appears to us as a point object, a dot like that, because it's very far away. Very less number of light enters our eye. So even sometimes we are not able to see stars also because the light is not entering. Even light is entering, then more bright light is entering to our eyes, then we are not able to see. So in the daytime हम दिखते हैं, मतलब बहुत ही कम दिखते हैं stars को. Or when it is afternoon, you cannot see at all because more bright light enters our eye, so your eye detects the bright light image, the bright light source behind, but you cannot detect then the dim light source. So dim light source तो stars हैं तो क्योंकि they are very far away and very less number of rays entering our eye. That's the problem. Moon, if you divide into so many point objects and every point objects has the same phenomena again, and because of the variations in atmosphere, so atmospheric condition fluctuates, then the amount of light entering our eye also fluctuates, and sometimes the one point may be brighter and the other point may be dimmer. So if there are 1,000 points, the 500 point may be brighter but the other 500 may be dimmer. So the average effect is bright only. Average effect is bright because some of the points is brighter always and some of the points are always dimmer at that particular instant of time. So the average effect So moon can be considered as collection of so many point objects. So the average effect of amount of light entering is stable here, because maybe 50% of the points may be bright and 50% of the points may be dim at a given instant of time for a viewer. So that is why moon does not twinkle, right? So you can read through your textbook and underline those points given exactly in your textbook as an answer. So I will read out the answer from your textbook. I will read out the point from your textbook, how you should underline and learn it. So for twinkling of stars, there's a paragraph given and it is written: the starlight on entering Earth atmosphere undergoes refraction continuously before it reaches the Earth. So since the starlight atmosphere bends always towards normal, the apparent position of the star is slightly different from its actual position. Further, this apparent position of the star is not stationary but keeps on changing, since the physical conditions of the Earth atmosphere is not stationary, and the physical condition of the Earth atmosphere is varying. So what happens is, since the stars are very distant, they approximate point-sized source of light. As the path of rays light coming from the star goes on varying slightly, the apparent position of the star fluctuates and the amount of starlight entering the eye flickers. The stars sometimes appear brighter and sometimes fainter, which is known as the twinkling effect. Then why don't planets twinkle? Why don't moon twinkle? The planets are much closer to the Earth and are thus seen as extended source, not point source. So there are two things here to understand. One is a point source. So one of the reason behind is point source and extended source, large source. And other is the physical condition of the Earth atmosphere varies. Physical condition varies of Earth. Physical condition of Earth, that is another reason. And then apparent position is another reason. Apparent position of the star fluctuates, and apparent position is different from the actual position due to refraction. So refraction may bend towards the normal, or bend towards the normal वजह से apparent position of the star or whatever it is, sun or moon, whatever it is, apparent position is different, because हर चीज के लिए refraction तो होती है. As light enter from vacuum to Earth's atmosphere, then it will bend towards the normal, क्योंकि ये denser medium है. So bend towards the normal. So apparent position is then different from the actual position. Then due to physical condition of the Earth varies, then the apparent position varies. So as they are considered as point source, very less number of rays enters our eye. So sometimes it appears brighter due to more number of rays entering our eye, and sometimes it looks fainter due to less number of rays entering our eye. As the apparent position changes, less number of eyes enter sometimes, and sometimes more number of rays enters. So which makes us feel that the stars twinkle. But the planets and the moon are seen as extended sources, collection of so many point sources. So that also I will read it from your textbook. What I have explained is the same as your textbook is. The planets are much closer to the Earth and are thus seen as extended sources. And if we consider planets as a collection of large number of point-sized sources of light, the total variation of the amount of light entering our eye from all individual point-sized sources will average out to 0. So the total variation is individual point में से जो variation आ रहा है हो सकता है कि 500 point में से, as an example I told you 500 points, it could be thousands of points, could be lakhs of points, but जितने भी points आ रहे हैं, है ना? So collection of extended sources है, तो extended source collection, extended source is collection of point sources होता है. So इसमें से 50% जो है brightness को अगर पैदा कर रहा है आपके eyes में, और 50% हो सकता है डार्कनेस, मतलब फेंटर लाइट होगी, यानी वीक लाइट होगी, या लेस नंबर ऑफ रेज होगा, लेकिन एवरी टाइम इट इज सेम. सो द एवरेज इफेक्ट जो है वो ब्राइटनेस ही आएगी. सो एवरेज इफेक्ट में कम ज्यादा ब्राइटनेस नहीं आएगा. because there are so many point objects. But when you consider a star, it is just a single point object. Okay, so that's all about this. And there is one more topic when we talk about the atmospheric refraction, that is advanced sunrise and delayed sunset. So what is advanced sunrise and delayed sunset? Advanced sunrise and delayed sunset. So what will I teach and what will I write on the board, what will the diagram I make, you have to make in your fair copy. So advanced sunrise or delayed sunset. So sun is earth is here and sun is at a distance giving us light. So a person on suppose a person over here, अभी मैं यहाँ पे consider कर रहा हूँ. So a person over here, when he looks, so earth की size के हिसाब से person तो फिर dot भी नहीं है ना, क्योंकि earth is very very bigger than a person. So person तो फिर उसके सामने एक dot भी नहीं है. So person तो यहाँ भी imagine करो कि यहाँ एक person है, and when he looks for him, this is called horizon. Horizon means he cannot see below this, क्योंकि फिर अर्थ का जो ये पॉइंट ऑब्जेक्ट तो मान सकते हैं आप, अर्थ इज अ बिग very bigger object, then the person is a point object, and the earth's surface will is an obstacle to his vision. क्योंकि हम ऊपर की तरफ देखते हैं या सामने की तरफ सामने कोई बिल्डिंग है तो फिर हमें पीछे वाला जो चीजें दिखता नहीं है, बिकॉज द बिल्डिंग इज एन ऑब्स्टेकल. सो यहाँ पे बिल्डिंग हो या ना हो, लेकिन अर्थ इज एन ऑब्स्टेकल फॉर अस, सो वी कांट सी अलोंग थ्रू द हॉरिजॉन. सो हॉरिजॉन के नीचे हम देख नहीं सकता, इसको हॉरिजॉन बोलते हैं, क्षितिज, हॉरिजॉन. सो हॉरिजॉन के ऊपर नीचे जब सन आता है, सपोज या सनसेट की बात करते हैं, सनसेट की. सो दिस इज एटमॉस्फेयर ऑफ द अर्थ. सो व्हेन द ray of light incidents like this, so horizon, I am going to take it out. This is an imaginary line that you can understand that this is horizon, below which आप देख नहीं सकते, और ये जो ray of light को ऐसे जाना चाहिए, but what happens is the ray of light bent towards the normal and enters the human eye. But for human being, he can see only straight line image. So this is the apparent position of the sun. So that is why I told you the apparent position is for everything, whether it is for a planet, for a sun, for a star, but apparent position is there, क्योंकि refraction of light होती है. So this refraction of light causes apparent position of the sun, a different position of the sun, and the position of the sun is slightly above the original position. So it means that even when the sun is not above the horizon, अभी ये horizon के ऊपर आया नहीं है, लेकिन फिर भी ये horizon के ऊपर आपको दिख रहा है. So 2 minutes before you can see. So suppose this is sunrise, and this is east. Suppose this is east and this is west. So even before the sun rises, actually 2 minutes before you can see the sun, due to the apparent position of the sun. So sun is actually below the horizon, but you can see the sun above the horizon. So this is due to the refraction of light. And sunset, when I talk about sunset, sun will set over here. So suppose the same thing I am talking about sunset here. Okay. The sun has actually already gone into the, है ना, अभी तो मैं राइज की बात कर रहा था, तो सन इधर आ गया, सन इधर से इधर मतलब एक्चुअली सन इज नॉट कमिंग हियर, but the earth is revolving around, and earth is rotating and as the earth is rotating, then we can see that the sun is stationary there. According to the earth, sun is stationary anyway. According to the earth, sun is stationary. But for a minute, let's forget about that, क्योंकि फिजिक्स में रिलेटिव मोशन है ना. अगर आप चल रहा है और एक ऑब्जेक्ट रेस्ट में है तो यू आर इन मोशन, लेकिन स्टिल अगर आप रिलेटिव बात कर रहे हैं, जो ऑब्जेक्ट रेस्ट में है उसको भी मोशन में कह सकता है. सो दैट इज द रीजन व्हेन यू आर सिटिंग इन अ बस, सिटिंग इन अ कार एंड यू मूविंग और गोइंग लुकिंग एट द साइड्स ऑफ द ट्रीज ओवर देयर, आपको ऐसा लगता है कि ट्रीज भाग रहे हैं. हालांकि ट्रीज नहीं भाग रहे, ट्रीज तो वही है, लेकिन आप अपनी गाड़ी में भाग रहे हैं. लेकिन आप वहां पे बैठे हैं इसलिए आपको भागने का भी एक सेंसेशन नहीं हो रहा. So when you are in a train, when you are in a bus which is moving, you feel like the things outside is running away from you. The things outside is not actually running away from you. You are in motion. But with physics, relatively, आप जब रेस्ट में, आपको रेस्ट में मानेंगे तो फिर वो मोशन में है. Even though actually you are moving, but relatively we can say that when you are at rest, then the things outside are moving. Actually things outside are rest and you are moving, but both the conditions are same in physics, the relative motion we say it. So यहाँ पे सन ऊपर आ रहा है नीचे आ रहा है, इसका मतलब ये नहीं कि सन ऊपर नीचे जा रहा है. हम एक रिलेटिव मोशन की बात कर रहे हैं. हम सपोज कर लेते हैं कि अर्थ रेस्ट पे है तो सन ऊपर नीचे जा रहा है. So when the sun is here already and the sun has no reason, when I am talking about sunrise, सन तो अभी ऊपर आया नहीं है, फिर भी हमें सन का करंट पोजीशन यहाँ दिखता है. और इसी तरह सनसेट में व्हेन द सन इज मूविंग डाउन, है ना, इस साइड में बनाना चाहिए, लेकिन मैं अभी एक ही डायग्राम के साथ एक्सप्लेन कर रहा हूँ. सपोज दिस इज वेस्ट एंड द सन इज मूविंग डाउन, एंड सन इज मूविंग डाउन व्हेन द सन हैज ऑलरेडी मूव्ड डाउन द हॉरिजॉन. अभी आपको सन नजर नहीं आना चाहिए, लेकिन फिर भी 2 मिनट तक आपको सन नजर आएगा बिकॉज ऑफ द अपेरेंट पोजीशन. थोड़ा और नीचे जाएगा तो ये अपेरेंट पोजीशन भी नीचे चली जाएगी, and then you cannot see the sun. So after 6 o'clock आपको सन, या 6 o'clock 7 o'clock आप सन दिखते नहीं है, ऐसा लगता है कि सन गया और नीचे चला गया. So that is due to the it has went down into the horizon. और वैसे वो went down in the horizon वो नहीं किया, actually अर्थ ने किया है. अर्थ is rotating, so it is coming away from the sun. That's what. ठीक है. सो एनीवे वो ये जब ये फिनोमिना की बात करते हैं, इस तरह की चीजें बात करते हैं, आप रिलेटिव मोशन के हिसाब से करो. सो दैट विल बी इजी फॉर अंडरस्टैंडिंग, है ना. लेट्स थिंक दैट सन इज मूविंग. व्हाट इज द प्रॉब्लम इन दैट? बिकॉज वी हैव केप्ट अर्थ टू बी स्टेशनरी देन. सो दैट इज रिलेटिवली सन इज मूविंग. Actually the earth is moving, but when the earth is kept stationary, because we are standing on the earth, we feel like we are stationary. And just like when you are moving in a bus or a train, you feel like you are stationary because you are sitting inside. You are not experiencing that, if it is a smooth ride, you will not even experience that it is moving. अगर आप कभी फ्लाइट में गया है तो आप इस बात को एक्सपीरियंस कर सकते हैं. फ्लाइट के सारे विंडो बंद है, and you are inside this flight. And your flight may be flying at a distance, flying at a speed of 1000 kilometer, 1200 kilometer per hour. यानी इतना खतरनाक स्पीड से जा रहे हैं, 1200 किलोमीटर पर आवर. लेकिन you are sitting inside the aeroplane in the flight, and all the windows, suppose all the windows are shut, and you can't see outside what is happening there. You cannot see the clouds, the windows are shut. And only you can see, air hostess are moving here and there, and the people, when the flight is stable, you can also move. And you can go to the toilet, you can move there for your necessary things. So, you will really feel like the flight is not moving. I felt it several times. I felt that why the flight is not moving. And when it was, going up, you felt that, okay, something is happening. But when it is in the stable flight, when it is moving at a speed of almost 1200 kilometer per hour, but you will feel like the flight is not at all moving. You are just stable over there. You are sitting in a cabin, you will feel like you are sitting in a cabin. You are sitting in a stationary thing. So that is a feeling it comes because you are not straining to move anything. The flight is moving and you are inside. You feel like you are a stationary object. So that is the same thing here. When we are on the earth is rotating, but we don't feel that earth is rotating. We feel like we are stationary and the sun is moving, but actually what is happening is the earth is moving. So we have to know that there is a relative motion, and relative motion, when I say earth is at rest, I can say no problem, the sun is moving, because relatively sun is moving with respect to earth. Even though actually earth is moving, but sun is moving with respect to earth. Sun is changing its position with respect to earth. So that is what we are talking about here, है ना. सो 2 मिनट बाद भी, है ना, सनसेट के 2 मिनट बाद भी आप सन को देख सकते हैं, और सनसेट से 2 मिनट पहले भी, सनराइज से 2 मिनट पहले भी आपको सन दिख जाता है, बिकॉज द अपेरेंट पोजीशन कम्स अप. व्हेन इट गोज डाउन आल्सो अपेरेंट पोजीशन कम्स अप. सो सनसेट के बाद भी आपको अपेरेंट पोजीशन दिखता है. सो दैट इज कॉल्ड एयरली सनराइज एंड डिलेड सनसेट. ऑलमोस्ट 2 मिनट का डिले और 2 मिनट का एयरली सनराइज होती है, due to refraction of light, and it's a continuous refraction through the atmosphere when ray of light enter from vacuum to the air. Okay, so rest of the things we will learn in the next video.